My name is Trevor Dirksen. I work for NILEX Civil Environmental Group. I am the President and CEO of NILEX. I'm joined by a number of my colleagues as well as a number of our partners from TERANAP, from overseas. So we've got some people from both France and from Germany joining us to help us present this great product to you today. This webinar will last a maximum of 1 hour. And as I've mentioned, please keep yourself on hide on video and yourself muted, but please feel free to submit questions through the chat function. And please feel free to keep your questions to the end if you want to ask it live. You can do so at that point. I'll briefly kick off and just do a quick introduction of NILEX as an organization before I turn it over to a few other people. So NILEX has been incorporated for 43 years, head office in Western Canada, and we have locations throughout Canada and the Western US. We have a list of our offices there. We have formal offices with staff in Vancouver, Edmonton, Calgary, Saskatoon, Toronto, Salt Lake City, and Denver, as well as a number of satellite offices as well. Our role is really one that we feel is all-encompassing in geo-environmental and civil sectors. So we go all the way from design to logistic to installations. So we can help with design, distribution, logistics in many different industries, but as well as the installations. Our focus markets that we serve are the oil and gas market, mining, infrastructure, and the pipeline sectors. Today, we're going to focus specifically on containment and more specifically on a BGM product called TERANAP. So I'll let you read this for yourself. I won't do it justice by trying to get as technical as some of our presenters will be. But we have been working with BGM for a number of years, but have now just joined forces with the people at TERANAP. And we are excited about this long-term partnership that we've created with them. And we feel like this is a great product for us to help a number of our clients in all those different industries with any of their requirement for liner. What we're seeing is a huge uptake from different liner styles to BGM for a number of different reasons, which Frederick from TERANAP will get into shortly, and I'll introduce him. Lastly, what we'll mention, and we'll go through this, Frederick will take us through this in detail, and he's going to share his screen for the technical part of this presentation. But when we consider the reasons that people are switching to BGM and specifically to TERANAP, there's really four reasons. One is the conversion from conventional methods. The other is the cost effectiveness, whether it's from installation or whether it's from less maintenance and longer durability. It also goes hand in hand with a technical certainty. And then there are environmental benefits and construction efficiency. That the product is very easy to lay down and install compared to many of our other products. And for many of the people that are joining us, as you know, dealing with the environmental conditions we are here in things like winter installation or wet installation, we believe that this product has a significant technical advantage versus a number of other incumbent products. So there's a couple of technical experts that you're going to hear much more about today. There are two. One is Frederick de Martini is the Export Sales Development Manager for TERANAP. I had an opportunity to meet Frederick at their plant in France, and Frederick has traveled over to Canada a number of times, and he's got a personal connection to Canada as well. But Frederick's got 20 years experience with TERANAP and has shown some very strong case studies to us around projects that they've done around the world, both converting to TERANAP as well as the longevity of the projects. Second is Khaled Hosso, who is our operations manager for our installation services. Khaled comes with 19 years of construction experience and experience with all types of different geomembrane materials. Khaled is our most senior person that is on site managing our crews day in, day out, as well as our project management teams for NILEX. So this is the last part of the NILEX team where beyond going for the design and the supply, where we go all the way to the installation. And Khaled will talk about some of the installation techniques of the BGM. So with that, Frederick, I'll ask you to share your screen and you can kick off your portion of the presentation, please. Frederick?
Okay. Can you hear me?
Yes, you can.
I think you need, Trevor, you need to stop sharing your screen.
Very well. Sorry, done.
Penelope, you want to start?
Yes, okay, thank you. Hi, everybody, I'm Penelope. I'm working with Frédéric at BMI in France. So I'm quickly introducing the group just for you to understand better the scope. So please, Frédéric, the next slide. So here, just to give you some key figures about BMI, the number of square meters we sold, the fact that we have numerous manufacturing in all over the world. We have also R&D facilities. We have academies where we provide some training also. We are around 10,000 people, and we are working with countries where we are really and properly established with some headquarters, and we are also working with a lot of other countries, and this is with the export department. Next one, please. So basically, BMI is the coming together of two different activities. The brass monnier, which is the pitch roof part with all the roof tiles and roofing components. And then Icopal and C-Plast is more the flat roof and the waterproofing with all the flat roofs, the active roof, which is more the blue roof, green roof, and the civil engineering, and where we are today talking with the TERANAP system. So yes, so Standard Industry, it's the parent company, and then you have one side GIF, dealing with North America, and within is C-Plast US. And on the other side, we have BMI, so in Europe. And inside BMI, you have different brands as the C-Plast, Cobber, Icopal, etc. And today, the TERANAP, so the name of the range, the geomembrane, is part of C-Plast. Next one, please, Frédéric. Okay, I just said we are working with many countries. Today we get a large and a longer experience with some very diverse climate conditions, with some different projects. And if you want to learn more about this project and follow what we are doing day by day, you can follow our page in LinkedIn, BMI International. I'm about to put it in the chat so you can reach easily this page. I think that's it. The next one, it's you, Frédéric. Okay, thanks, and I hand over to Frédéric.
Good morning, everybody. My name is Frédéric de Martini. Thanks, Trevor, for the introduction. Please don't complain about the accent, because we know, everybody knows that Canada is a bilingual country, so if you complain, I'm going to talk French, and then you cannot say that you don't understand it. I know it's a terrible joke. I do it all the time. Nobody laughs, but I like to do it. So let's talk about bituminous geomembrane. It's I'm sure most of you know about HDPE. If we had to talk about let's say the two main differences between HDPE and BGM, bituminous geomembrane. First is the thickness of it. It's so much thicker. We'll show it in details later, but we're talking about membranes which can go from, let's say, 3 to almost 6 millimeters thickness. And you can see that here in the middle you have a reinforcement which gives the power of the membrane. The reinforcements they have different functions. So about mechanical performances, of course, about tensile stress, static puncture, dynamic puncture, and torque resistance. Without it would not work. So we need to add, and it's a very important point for our, let's say, production process, and it allows us to, of course, to manufacture it. If not, we could not do it. And we can storage it a very long time and move it in the field and even in the factory. It's important to say that this type of production, I mean, the membranes themselves, the bituminous membranes, they come from the roofing industry. So it started in the 50s with roofing, and then a fantastic guy in our company in 1974 decided he tried to do it with large width, and at the beginning it was in France to respond to the water industry in France for canals, most of it, and of course the installation. It's very easy to install and to weld it. Okay, so for you to know, there are mostly two types of reinforcements in the middle: the glass fiber and the polyester. So what gives the stability is the glass fiber. It doesn't move a lot, so it gives that stability we want, but it's not very good for puncturing. So it could be a problem in our big jobs. So that's the reason why we produce it with two reinforcements in the middle, and we have glass fiber and the polyester, which gives the puncturing resistance we need. And we also need, it's like we ask the membrane to be resistant and flexible at the same time. So it's hard to have, and with those two reinforcements we can achieve it. It was for you to understand, let's say, but we're talking about a geomembrane. But different from, I think most of you know, let's say a GPE or PVC or EPDM, but they are the same fields of use, more or less. Mining wastes, we work a lot in mining wastes, mostly South America, but also Australia, Africa. So it's interesting because we can have many different experiences with different kind of metal, gold and copper and lithium, and different kind of subgrade too. So it's interesting too. Also, we do a lot of hydraulic jobs. The water industry. Water industry can be canals, but also dams, electrical dams, or dams for potable water. It's never the same, and this is what makes that job very interesting. But we can also see, we can also use that membrane in for transportation, tunnels, but also bridges, and also for construction, for tanking. When we build a building near the sea, if we have a basement, then obviously we need to protect the concrete. Okay, so I'm sure as I said, I'm sure we have a lot of PhD HGPE lovers here. So it's not a presentation against it. We don't have anything against, but okay, we are trying to explain what we think it's better. Why do we think that BGM has got better behaviors than the other ones? So first is the flexibility. It's a product which is well, as it comes from bitumen, it's very flexible. During the job itself, if you have special geometric shapes, it's very easy to adapt. But also the flexibility is about well, low temperatures, and you know what I'm talking about. Being Canadian citizens, you know what low temperature is. For just a personal parenthesis, as Trevor said, I have personal connections with Canada. It's absolutely true because my wife is Canadian, so I know what Canada is. I didn't know what minus 27 was. So I can tell you that well, we think that BGM is the best geomembrane talking low temperature. If you ask me, well, until which temperature can we work? I mean, low temperature we can work with it. It's not really easy to say. We did it at minus 15 and it worked in Finland, for example. But then, I mean, is it worth it to work and to send workers when it's that cold? This is another subject. But it's not just about the low temperature. It's also about the stability, about the variations of it. I mean, as I said at the beginning, we also we have a lot of experience in Africa. In Africa, it's the other problem. I mean, the other way around. We can have 45 degrees, for example. So it's not just the tests we can do in a lab, but it's also the experience. And it's very important for us to try to demonstrate that yeah, when the experience we have, as I said the membrane is 46 years old. So we have enough experience to say, okay, we can do that with BGM or not. Sometimes it doesn't work. So the behavior, well, it's very easy to weld. We are working with Nilex, for example, with a very revolutionary system to weld the membranes between themselves with air and not with a burner, which is a different kind of burner. So it's always a work in progress too. But anyway, it's very easy to connect with 20 centimeters overlap. And we also have, because I know we'll have the question, we also have a possibility to test the overlaps. It was not possible until now, but we have great engineers in our group, and they found a solution to test the overlaps. So then connections, yeah, I mean, concrete, for example, it's very easy with a primer first. You have to do an imprimation of the concrete, and then you can weld it perfectly. And that experience also comes from the roofing industry. We did incredible very complicated roofs, and then we also have to deal with concrete. So we know what we talk about, and then obviously all the connections are easy to connect with BGM. The wind here, I wanted to say that well, it's a very heavy geomembrane. Well, between 4 or 5 kilos per square meter. So you don't have to ballast it that much as you have to do it with HGPE. Obviously, you have to, but it's so much heavier. And then the temperature of it too. You can work, yeah, let's say from minus 15 to 42 Celsius degrees. Once again, depending on what you want to do with the workers, but I mean, technically, theoretically, it's possible. Very easy to repair. You just have to take one part of a membrane and just do a repair with it. Well, aging is the key. it's when product is new, then yeah, it's like every product is fantastic. But then how much time is it going to last? So as I said, with the experience we have, it's well easier for us to demonstrate what we did, and I will talk about it in details later. Chemical resistance, yeah, the same thing. We also this is maybe where, to be absolutely honest, where we are maybe not better. For example, hydrocarbons are not. I mean, our TERANAP doesn't really like it, so we have to work on it. But mostly, when we talk about mining, cyanide and everything, knowing the concentration and temperature, we can give you a report and prove that that it's going to last. And for example, the cyanide is not going to attack the TERANAP. I mean, I think that if we have to remember one slide, I think it's this one. It's a very simplified, of course, but it's just to try to explain the difference between a product which is an elastomerical, which is absolutely flexible, and then another product, for example, HGPE on the right, which is just a plastic, right? So you have on the left the breaking points of the geomembrane, the bituminous one, which is around 38%, and it stays absolutely flexible, okay, elastic. Sometimes it's elastic, sometimes it's elastical, sometimes it's magical. I'm sorry about the struggle of English. But on the right, you can see that, yeah, you have the same kind of elongation with HGPE, but around 18%, you're going to find what we call the yield point, where it's gonna stay. The round, the red round is not in the right position here. It should be in the yield point. But it's gonna from 0 to 18 is gonna stay elastic, and then it's not the HGP is not going to come back to its former shape. To its former shape, it's gonna stay plastic. So it's very, very important difference between the two. So another difference clearly is that with the BGM, we don't have any stress cracking. So you cannot see, this is obviously those pictures are taken from HGPE, and you can see those waves because of the sun mostly. With the BGM, you don't have it. You don't have those stress cracking. So I would say in French, robust, right? It doesn't move. It stays absolutely smooth, and you can work on it and weld it the same way. So you don't have to wait. I'm talking maybe more for let's say sunny countries, but you have sun sometimes in Canada too. So what I mean is that if you unroll a membrane, HGPE, for example, and then you're gonna have the sun on it, and you're gonna have those waves, and you have to wait for the weather to be better, and then you can install. With the BGM, you don't have those problems. You don't waste that time. Another big advantage is the friction angle, which is around 34 degrees. So it can make the general contractor big saving of money. Talking about an embankment. Sorry. This is the TERANAP range from 2.5 to around 5.6 millimeters. We also have you see on the right, TERANAP with a geotextile integrated on the top of it. So it can be interesting if you have very punctured aggregates. So, but normally, I mean, this is another key point. Normally, you don't need a geotextile underneath nor on the top of it. Obviously, it depends on compactation of the subgrade, and depends on the how punctured the aggregates are going to be. But this is the whole range. Normally, we start from. You can see we produce from. Well, we can also produce in 1 meter for some details, but normally it's 2 meters or 4 meters width. And we also can do it if it's an important project. I mean, important, talking about quantities. We had a job in Lebanon last year, a dam, and we did it on, I mean, we did the length that the job needed. So here you can see it's 100 meters or 90 or 75. But if the job needed 82 or whatever, we could do it. It's not an issue. We can do it exactly like tailor-made. So we talked about. I mean, what is important is the aging. Okay, so when this product is new, is great, and then what's going to happen in 15, 20, 30 years? So there are solutions to do it in laboratory, but it's always very theoretical. So this is an example of a job that my friend Trevor, who is listening, did here the presentation from CPLAS USA. That did it in '91. It is a canal in Kasparkova in USA, and 25 years after, they went back on site and they took real samples to see. Well, it was an external laboratory, of course, and they took samples from exposed areas exposed to the sun, and non-exposed areas to do tests and to see what happened after all those years. So this is very interesting. And to make a long story short, you can see that there are like 3 points. Well, the first point is the thickness, which was for those to know the TERANAP 431. Which has a 4.10 millimeters thickness, and they did 3 tests: the average peak load, the average elongation, and the low temperature flexibility. So the average peak load, I don't know if you can see it in the picture in the middle. You can guess a line, a blue line, and then 2 green stuff. Let's say average peak load would be let's say the quantity of materials that was lost in the process. So the reinforcement, as I talked at the beginning, is in the middle, and you can imagine that. To reach the reinforcement, we will need years and years and years. So the material just lost a few and nothing. So, but there is no difference between the exposed and the unexposed parts. And we'll see in the two first tests, the 2 next tests, that it's a bit different when we talk exposed and unexposed. So the average elongation, which when in the unexposed sample is still 80%. When it was exposed to the sun, it's a little worse, from 62 to 65%, but it still remains very, very, very good. And about the low temperature flexibility, there is a difference too. We can see that in the unexposed sample, we've got a still minus 24 Celsius low temperature flexibility, which is like a new product. And we just have -6, but you know, after all those years, it's very good performance. So what the lab concluded is that you can see sometimes if I come back here, for example, if you see on the left, can I point it? Yes. Here you can see here those little like a crocodile effect, let's say. It's nothing, and it doesn't affect the let's say the performance of the membrane. Those cracks are just aesthetical. Then the mechanical performances still remains fantastic after all those years, and so the water tightness, which is the capacity to waterproof, is still performing very well after 30 years. So this is the question when, you know, we're talking about guarantee or warranty, what can we give? So this is also a very, very important point. So what are our strengths? This is the unique BGM with 46 years of experience. To be absolutely transparent, you know, there is another BGM producer, which is also French. So we are the unique BGM producer with 46 years of experience. When I wrote here perfect control of our manufacturing process, it seems obvious, okay? But can you imagine how it is to respect for example, in a membrane, geomembrane of 400 square meters, how can you say you have 4.10 millimeters everywhere? So this is what we can do. Once again, thanks to our experience, we have the same thickness all along. If you see what I mean. The BGM with higher mechanical properties, sometimes it's true, sometimes it's not. If those who would be interested by it, I could send, or Nilex obviously could send comparisons of it. But in most of the cases, we've got the best technical properties. And we have the TERANAP control. We can do a control of the seams by a new technology, and believe me, we are the only ones able to do that. We also have a certificate for potable water. So when we work for dam, it's absolutely, or canal, it's absolutely an obligation, mandatory. It's the word I was looking for. Very high, as I said before, very high chemical resistance, and we saw the one example of a real test we did to demonstrate the resistance to aging. But if you needed more experiences about it in other kinds of jobs, we have them. And obviously it's always done by external labs, so that we can prove it. So yeah, the mechanical performances are very high, and for tensile, but also with puncturing resistance. It's important to say that because I repeat myself saying it's easy to install. Okay, it's not. I mean, you cannot become a BGM worker in one day, but this is where I think we are strong, because we have a training center in France. We have engineers and technicians who can assist if the customer, if your customer needed it, and say, okay, fantastic, we have an installation company here, but where is the producer? The producer is not just a salesman. I can tell you, we are a real partner, and this is really, I think, where we make the difference, because we are involved in our projects. It's not just, as I said, we're not just a producer. We try to work from the beginning with you guys, engineers, to try to specify and say, okay, we recommend 4 millimeters or 5 or whatever. So yeah, and then we have the training center, training teams to help you. Yeah, TERANAP is got that North American certificate for potable water. I don't know if I'm going to go through all those details, because it's a lot, I think. But yeah, I mean, I know that it is that presentation is recorded, but in every job we can show the differences and the advantages that the BGM has compared to other solutions. And but I think it's a bit too much to and a bit of a repetition to go through all the lines. So I don't know if you have an eye, you can see somebody very important in those pictures. On the right, upright, you can see an important man torching. This man is Trevor from Nilex. So we can also make CEO working hard. So can you imagine? Sorry for the bad joke again. But well, it was, as Trevor said, in February, last February, he was in our factory just before the crisis. So fantastic. And I said to him, well, if you wanna work with us, I'm sorry, you have to weld. So he did it very well, and you can see also our engineer Pierre helping and training him. So those pictures here are not there by chance. I mean, they are selected because we want to be your experts. We want to show you that we know when which kind of BGM to recommend and to specify. And also we certify our the installers that work with us. Well, I have to say it's more for for Canada. We know that the installers are good anyway, but in some other countries it's a bit slightly different. So we need to most of the time to train from scratch. So it's different. And you can see a picture here that I love on the left bottom left, in Lebanon, in a dam, where you have an experienced, unfortunately retired now, engineer of ours, and then a new one, our friend and co-worker Pierre, and they are there to go through all the details. Obviously, we're not an installation company, okay? Because Alex does it for us in a way, but we know what we talk about because we are very close to the jobs, to our customers. This is the job before. I'm very proud of it. I'm sorry, but it's a big success. And the after, well, not the after, but it's the work in progress. It's not over. But this is an example of, I think, a great case study that, once again, all the details you want, all tests, everything you would need, reports, whatever, we'll do anything to send it to you. Some successes in countries, well, South America, but also Australia, Canada, of course, and Africa. Graphite mining, lithium, copper, gold. So this is the manufacturing. Sorry, factory is in France. In the middle of the countryside, in the middle of the cows, you have a fantastic bitumen smelling when you go and visit the castles of France, right? If you have time to visit beside the Eiffel Tower, you can go and visit the castles and of course our factory, which is over there, and it's a big factory. Mostly for roofing, I have to say, for roofing lines, but also for us, for geomembranes. This is the factory itself. On the bottom left, you see our training center, where many roofers and BGM installers were trained. Well, we do every time well, this is more for Europe here. All the standards and everything, but we also comply with ASTM standards. Everything is on our data sheets, obviously. Which is an example here. And a few words about the SIM control technology. We were always criticized because, well, you besides of your accent, it's all perfect, right? BGM is all perfect, but you don't have a SIM control technology like AGP. Okay, we're working on it, and we are a great technical export department invented it. So it's really the unique bitumen geomembrane with an integrated SIM control. And once again, it's very easy to use, and we can also send you videos, which would be better to understand it. But you can see, for example, here in the picture on the left, you can see in the middle we have that control channel, and we send a gas, diazine, so in English. Which is it's a very rare gas. It's not it's not a mechanical test. It's a diazine gas we inject in here in the channel, and then we're gonna go with that tool here, that gas. We're gonna smell, let's say, if there is gas going out. For those who are interested, once again, we have videos. It would be maybe better, easier to understand. But you can see here, it's quite simple, and you have that bottle of diazine, and the guy sending the gas inside, and then controlling with the tracer gas here, and to be sure there is no leakage. Voilà, merci beaucoup. I can answer a question. I saw some questions maybe on the.
There are Frederick. There are two on the chat that I think are both probably more directed for you. So we can take those now. The first one is the deformation that you mentioned elastic? Does it take its shape, and does it come back after deformation?
Oh, is this version elastic? Does it take its shape back after deformation? Of course. This is what we want from a bitumen and geomembrane. It goes let's say on and off, and it moves all around let's say the movements, and obviously it comes back. Oh well, if you have a earthquake in Chile, maybe not. You know, there is also a limit, and the limit is done or is given by the reinforcements themselves.
Okay, thank you, Frederick.
Yeah.
The next one is, how does the product compare to Coltanche?
Well, thank you, Miranda. It's a great question. Well, to be absolutely transparent, we produced Coltanche for them for many, many years. So they were clever. In 1999, they decided to have their own line. And so we know perfectly what they do. It's a great product, but as I said before, the experience we have, we cannot compare. You cannot compare the experience. Well, to be absolutely honest, it's almost the same product. There are a difference. They have a 5 meters width. We have 4. You know, because we started with it, so we took all the risks, and then they said, okay, we're going to do a little, let's say, a little bigger, and they were very clever. But about performances and about, let's say, well, yeah, let's say in general technical performances, we are better, and we can prove it just comparing the data sheets.
Thanks, Frederick. The rest of them look like they're getting into some installation questions, so maybe we'll hold those till the end, and maybe turn over to Khaled, who will take us through his portion of the presentation, please.
Okay. Hey, everyone.
Frederick, I believe you need to stop sharing. There we go. Thank you. Khaled, over to you.
Okay.
Perfect. Good day, everyone. Thanks, Frederick and Anatolia, for the wealth of information. Frederick, I don't think you'll be the only guy with accent in this presentation today. I loved your accent, and I hope.
Thank you. Thank you. So I love you. I love you.
Thanks a lot. Thank you. Trevor, thanks for the introduction. Good day, everyone. I appreciate the opportunity of being part of this presentation today. I would like to start by thanking the behind-the-scene partners who supported me and make this presentation possible, starting with my line manager. Thank you, Ayad. Pierre from C+, thanks for the information. My mom and my wife, I want to thank them and thank my wife for her patience. I love you. Back to quality. Today we are going to talk about the quality control procedures for the NILEX TERANAP, but before, let us highlight some advantages from an installation and end user perspective. NILEX TERANAP allow for multiple installation approaches. You can do the installation and we provide you with the key. This would be the most cost-effective method for you. We can also provide a welding team for the installation, or we can do a full installation crew with a turnkey solution. Another advantage of this product is that it's more forgiving in terms of subgrade preparation versus other geomembrane products. Another advantage is that it's easier to repair. You don't need to call us back like other geomembrane products. You can just simply, if you have your internal labor and you have few minor tools, you can do the patches and repairs yourself. Some equipment can drive over it. There are some limitations, but again, it's much more forgiving versus other products. And the most interesting part will be the flexibility installation and the various testing methods. Our installation team is feeling more and more confident about it in several applications like trenches, tank farms, erosion control, ponds, etc. We recently completed a 50,000 square meters pond in less than 8 days with a 10-man crew. We have been successful in welding it with Tiger torches and with wedge machines. Our supervisors felt confident about it more than other geomembrane products, and it's a great product and ready to roll. Back to quality. Where to start? First, understand the application. What are we doing? Accordingly, we can select like the product and select the welding techniques and a set of other tests. Second, we need to communicate expectations. And install methods are best suited for this application. Third, we update our ITP and prepare the tools accordingly. Then, before we arrive at site, we need to discuss some prerequisites. These are the things that need to happen for a successful installation before we arrive at site. First, the first activity is receiving material. The material has to be received in a certain way and stored in a certain way to ensure the integrity of the product. Subgrade preparation, Nilex TERANAP is more forgiving in preparation than other geomembrane products. We have our preparation manual that will guide you through that. Third thing need to happen is you need to dig the anchor trench before we arrive at site. We will discuss with you other terminations methods like the concrete attachments or whatever termination that is happening on site. Another thing we need to consider is the weather at the time of installation. You can see here on the right the picture of the anchor trench after installation, and on the right bottom you can see the mechanical attachment in case we are attaching to concrete. This is a picture for the product arriving at site. In the bottom left corner, in the middle one, this is the pole we use to offload the product. As you see, the product needs to be stored on site supports. This can be steel, can be concrete, can be wood blocks, as long as it can carry the weight of the roll. Here are some pictures of the tools we use for installation. As you see, some basic tools, torches, air pressure, etc. That's why we said it's very easy to repair in case accidentally a hole happen on site. Our biggest tool to install this product is our engineered spreader bar, and it comes with connection to be attached to different equipment on site. Another handling equipments that are required on site. The most common one is using a hoe because it gives flexibility in movement in all directions. We can use other tools, other machineries according to what is available on site. This is a repeated picture from previous slide, but this is also showing the welding process. In the bottom left, you can see the cross section of the weld and the lapping. We need the, depending on application, the width of the weld can vary, and depending on the method used for welding. In this slide, you can see some tricks during installation, how we shingle the panels according to the direction of flow of water. Also, where do we place our seams in case there is a slope or something during installation. In this picture, you'll see the patches. Patches happen in case of cross seams or in case there is a repair that we need to cover. In this picture, we see different penetration cases and how we deal with every one of them. All this magic happen on site. One of the main challenges while doing installation is the weather. Again, it's worth mentioning weather still affect the installation of this product, but again, it's much more forgiving compared to other products, especially with its weight and wind effect. It's much less effect on this, as mentioned in the previous part of this presentation. These are some pictures of installations happening in not favorable weather conditions, but still it's not like a blank check. We will need to discuss and assess case-by-case basis so that we ensure a successful high-quality install. Now, to the bottom of quality control, I'll go over some tests that are most commonly used. We start with the pre-qualification. Pre-qualification is the first test we do before installation. We weld the test piece and then we use a coupon cutter to cut the test samples to ensure that they pass the parameters required. The picture on your left-hand side, okay? Then after cutting the coupons, we use the tensiometer on the right-hand side to test them. The tensiometer acts like as like a verification of the testing method, whether we are using the wedge or we are using the torch. The tensiometer itself, we certify its cells yearly to ensure that it's giving us proper parameters. Another very common test method is the visual inspection. In general, like we are looking at anything that doesn't look okay, any fishtails, any overheating, underheating, anything that doesn't look fine, it's worth a zoom in, and accordingly we can apply the fix. Another test is the non-destructive test or Erlang's test. It's also most common use for this product. You will need a specific compressor with enough volume capacity for the test to be effective and successful. But after testing, this test can happen so fast and it really gives high assurity of the weld. Another test, also very common, also used in other geomembranes, is the vac box test. The vac box, we use it to test any patches or specific portions of the seams as per specifications. Destructive testing, it's very similar to the pre-qualification. We do it every certain amount of meters just to ensure that we have the proper parameters after welding. You will not expect a lot in terms of the peel test, but the shear test will be the tally most effective portion. TERANAP TP control, we are very excited about this test. We didn't get a chance to try it yet, but it provides another layer of assurance as it has integrated seam control system that allow for seam testing. It was presented in the first part of this presentation, so but it's really a great thing to have in DGM. Thank you very much, everyone, and I turn it back to Trevor and Tammy for questions.
Thanks, Claude. Yeah, there's a few more. Apologies to everybody. I know we're concluding the end of an hour, but we'll proceed with these questions. And if you have some more, please continue to put them in the chat. So the next question was, how do you test at the end of the roll cuts and patches with the leak seam control? Frederick, do you want to answer that one, please?
Yeah. Well, you said about the patch, about the repair?
It says, how do you do a test at the end of the roll, cuts and patches with the leak seam control?
Not with the patches. You cannot. The tests. I mean, the TERANAP control is done with the overlap just on the length of it. When you patch it, you can't. When it's when it's for a patch, if I understood well, you can't do the seam. The seam is the channel, the control channel is prepared in the factory. It comes with the channel integrated.
Okay, thank you. Next one is, it looks like there's a different overlap for mining versus construction. Can you speak to that?
Well, yeah, I mean, normally it's 20 centimeters when it's for mining or an hydraulic job for when it's 4 meters width. When it's for example, a tanking, you don't need that much. You just need 15 centimeters when it's for tanking. But normally it's because I mean we produce it in 2 meters too, but also in 1 meter. So, but it's something that it's a good question, because I think this is something we have to improve. I mean, why do we really need 20 centimeters? It's an old question. And now, thanks to you, Navex, we are working on a new kind of a new way of welding it, and maybe we can improve it and have less wastes too.
Okay, thank you. The next one is, I believe one of your slides shows the angle of repose of 34 degrees. Frederick, this was from your presentation. Is that standard, or does it only apply for specialized surfacing?
Well, obviously it's kind of a summarize of it, but we did tests some years ago with different kind of supports, with gravels and concrete, and it's never the same. And also it's not the same if you do it from one side, like the film part of it, or the sand surface of it.
And then how does the material have to be received and stored? What impacts are there on the product from temperature, precipitation, UV, or light?
Well, UV, there is no problem. Temperature, I mean, in all the jobs that we did, we never had any problems about that. As I try to demonstrate, obviously, if when the UV has an impact on the aging of it, so if it's undercover, it's not obviously the materials is less affected if it's not in contact with the UV. But even if it has, let me give you an example. I talked to you with a lot of pride about that job in Lebanon. Okay, you saw one of my last slide where you can see the whole BGM in contact with the sun, because as with all the problems that Lebanon had, explosion, political problems, the job is stopped. So the BGM is there. It's not covered by water, and obviously we'll do the test when it's the time to start the job again. But we know, we are very confident. The customer asked us, do we have to cover it with sand or with geotextile? And we said, no, you don't have to do it, because it's proved that it's resistant to UVs. Can you imagine the responsibility of us if we were not absolutely sure about this? We would not write it down. We would say, okay, we don't know, let's see. No, it was not. Was not. We didn't know this would happen. We thought that once the job once the job was about to be done, then it would be full of water, you know, but it's not the case. So UV is not a problem at all.
All right. Thank you. The next question is, how long is the training program for installation? What does the program involve?
Well, if you want to visit the country, I mean seriously, when we can travel, and if we can absolutely invite you. If you can come to Paris, and then we can have a 3-day training. Well, it depends if it's in which kind of role you have in your company. If you're an engineer, then okay. I think it's important to know how to weld, but you're not going to weld in your daily life. If it's for a technician, like a worker, then it needs 3 days of welding and to master it, because I confess I didn't really insist on it, but it's a teamwork, which you also have. You always have two people working together. One guy with one person with a welder, and another person with a roller to compress, to pressure the overlap. So if it's in the factory, it's a 3-day session, let's say, and if it's on site, then it depends on the job, and it can be also a conversation with the mining company or the general contractor. Say, okay, how much do you need? It's absolutely it's not, we don't charge anything. It's just for the needed, if it's needed, we can stay 1 week, we can even be at the beginning of the job to see if the subgrade is okay. Then we can come back in the middle of the job, and then at the end, just to be sure everything is done. But we are not let's say we're not an installation company. We are a manufacturer giving advice.
Yeah.
And that's the Nilex role Trevor steps in. During my first slide, I have mentioned the different configurations that we can work with clients. If they are interested in installing, they can install and we can weld for them. If they are interested in installing and welding, we can provide them the QC support. And then also we can also do the full turnkey package of installation. Whatever is the configuration they would like to do, we are more than happy to have a discussion with them and give them the solution in Canada that most suits their needs. Thank you.
Yeah, thank you, Claude. I was just going to say as well, and there's a follow-up question which I think has the same answer, which is, you know, if there are questions, by all means, please reach out to us. We'd be happy to discuss any specific job requirements you have, whether it's us helping with installation or guiding your own crews through it as well. We'd be happy to do that. Next question is, how much gravel cover is required to allow tracked vehicles to drive over the liner?
Yeah, this is the question. I'm sure it comes from Coletanche, because they say that it's absolutely okay to drive on it, and it's not true. I mean, you cannot pretend to do a race on a job and then nothing's going to happen. Obviously, there are conditions where I can send it to you. I don't have it in mind. I'm sorry, but I remember there is a limitation, and about the weight of the machine, and also how to explain that in English. The torsion, like you have to be the driver will have to be careful to, you know, to not to drive like crazy. I mean, but yeah, there is. We have to be very careful about this, because I'm sorry to say that some well, our competitor I know we said that once or twice, and we think it's a bit dangerous to say, yeah, everything is fine. So, but let me get back to you about this, please.
Thanks, Frederick. I'll just pause for just a quick second and see if anyone has any questions that they'd like to vocalize. That's the end of the questions that came through over the chat.
Okay.
All right. Well, thank you everybody for participating. Apologies that we've gone 12 minutes past the hour. Thank you very much to all of our presenters. If anyone has any questions, has any follow-ups, please feel free to reach out to anybody at NILEX, and we would be happy to follow up for you. This concludes our webinar today. Thank you everyone for attending, and have a wonderful day.
Thank you.